Top 20 Data Analytics Interview Questions and Answers. Data analytics is a critical skill in today's data-driven world, enabling organizations to turn raw data into actionable insights. Mastering data analysis requires not only technical expertise, but also the ability to interpret and communicate findings effectively. The following top 20 data analytics interview questions and answers will help you prepare for both technical and practical aspects of the role. 1. Can you explain what data analytics is and why it is important? Data analytics is the process of examining raw data to identify patterns, trends, and meaningful insights that support decision-making. It involves collecting, cleaning, and analyzing data to answer specific questions or solve problems. Data analytics is important because it helps businesses make informed decisions, optimize processes, reduce costs, and improve customer experiences. By transforming complex datasets into actionable insights, organizations can anticipate market changes, identify risks, and seize opportunities. It is widely used in industries like finance, healthcare, marketing, and technology to enhance performance, innovate products, and stay competitive in a data-driven world. 2. What are the main types of data analytics? The main types of data analytics are: descriptive analytics, summarizes past data to understand trends and patterns. Diagnostic analytics, identifies reasons behind specific outcomes or issues. Or predictive analytics, uses statistical models and machine learning to forecast future trends. Prescriptive analytics, suggests optimal actions based on predictions and constraints. Each type serves a distinct purpose in the decision-making process. Descriptive tells what happened, diagnostic explains why, predictive forecasts what might happen, and prescriptive advises what should be done. Combining these analytics types allows organizations to make well-informed and proactive decisions to achieve their strategic goals effectively. 3. Can you describe the differences between data analytics, data science, and business intelligence? Data analytics focuses on examining datasets to uncover patterns and generate actionable insights, often using statistical and visualization tools. Data science is broader, involving advanced techniques like machine learning, predictive modeling, and AI to create algorithms and predictive systems. A business intelligence emphasizes reporting, dashboards, and data visualization to track KPIs and monitor performance. While data analytics is about interpreting data, data science involves building models and solutions, and BI focuses on delivering user-friendly tools for decision-making. In short, analytics is insight-driven, data science is model-driven, and BI is reporting and visualization-focused. 4. What are the key steps in the data analysis process? The key steps in data analysis include: 1. Defining objectives. Identify the problem or goal. 2. Data collection. Gather relevant data from various sources. 3. Data cleaning. Handle missing values, remove duplicates, and correct errors. 4. Data exploration. Use statistical summaries and visualizations to understand data. 5. Data analysis. Apply statistical methods, algorithms, or models to find patterns. 6. Interpretation. Draw conclusions and evaluate results against objectives. 7. Communication. Present findings using reports, dashboards, or visualizations. Following these steps ensures that the analysis is accurate, reproducible, and directly aligned with business needs, enabling better decision-making. 5. Which tools and programming languages do you use for data analytics? Common tools for data analytics include Excel for quick analysis and reporting, Tableau and Power BI for interactive dashboards and data visualization, SQL for querying and managing databases, Python and R for advanced statistical analysis, machine learning, and automation, a Google Data Studio for free cloud-based reporting. Python offers libraries like Pandas, NumPy, Matplotlib, and scikit-learn, while R provides packages like ggplot2 and dplyr. Tool choice depends on project complexity, dataset size, and visualization needs. A combination of these tools allows analysts to efficiently gather, process, analyze, and present data insights for better business decisions. 6. What is the difference between structured, semi-structured, and unstructured data? A structured data, organized in rows and columns, easily stored in relational databases. Examples: sales records, customer details. A semi-structured data has some organizational properties but not strictly tabular. Examples: JSON, XML, log files. A unstructured data lacks a predefined format, difficult to store in relational databases. Examples: images, videos, social media posts. Structured data is easiest to analyze using SQL, semi-structured requires parsing tools, and unstructured needs advanced techniques like NLP or image recognition. Understanding these types helps analysts choose appropriate storage, processing, and analysis methods for maximum efficiency and accuracy in decision-making. 7. Can you explain descriptive, diagnostic, predictive, and prescriptive analytics? Descriptive analytics summarizes historical data to understand trends, for example, sales reports. Diagnostic analytics investigates why something happened, for example, root cause analysis for sales drop. Or predictive analytics uses statistical models and machine learning to forecast future outcomes, for example, churn prediction. Or prescriptive analytics suggests the best course of action based on predictions, for example, recommending pricing strategies. These 4 categories represent increasing levels of complexity and value. Businesses often start with descriptive analysis, progress to diagnostics, add predictive modeling, and finally implement prescriptive systems for fully optimized decision-making strategies across operations, marketing, and customer service. 8. What is data cleaning and why is it important? Data cleaning is the process of detecting and correcting errors, inconsistencies, or inaccuracies in datasets. It involves removing duplicates, handling missing values, fixing formatting issues, and standardizing data. Clean data ensures reliability, accuracy, and consistency in analysis. Poor data quality can lead to incorrect conclusions, flawed models, and bad business decisions. For example, duplicate customer entries can overstate sales figures, while inconsistent date formats can break analysis scripts. By investing time in data cleaning, analysts ensure their findings are trustworthy, enabling better forecasting, reporting, and strategic decision-making across the organization's operations and long-term planning. 9. How do you handle missing or inconsistent data? Handling missing or inconsistent data depends on the situation. 1. Remove records if the missing data is minimal and random. 2. Impute values using mean, median, mode, or advanced methods like regression or KNN. 3. Use default or domain-specific values if appropriate. 4. Flag missing data for further investigation. For inconsistencies, apply standard formats, validate ranges, and cross-check with reliable sources. The approach must balance preserving data integrity and minimizing bias. Proper handling ensures more accurate analysis, reduces skewed results, and improves the performance of statistical models or machine learning algorithms in data-driven projects. 10. What are some common data visualization techniques? Common data visualization techniques include bar charts, compare categories; align charts, show trends over time; the pie charts, represent proportions; histograms, display frequency distributions; scatter plots, show relationships between variables; a heat maps, highlight patterns using color intensity; a box plots, summarize data distribution and outliers. Visualization helps communicate complex data effectively, making insights easier for non-technical audiences. The right visualization depends on the data type, objective, and audience. Good visualizations are clear, accurate, and engaging, enabling decision-makers to quickly grasp patterns, trends, and anomalies in large datasets for informed decision-making. 11. Can you explain correlation versus causation with examples? Correlation measures the relationship between two variables, showing how they move together. For example, ice cream sales and sunglasses sales may rise simultaneously due to warm weather, They're correlated but not directly causing each other. Causation means one variable directly affects another. For example, increasing advertising spend may lead to higher product sales. Confusing correlation with causation can lead to wrong conclusions. Analysts often use controlled experiments, statistical tests, or domain expertise to determine causality, ensuring that decisions are based on true cause and effect relationships, not just coincidental associations in the data. 12. What are outliers and how do you detect and handle them? Outliers are data points significantly different from the majority of observations. They can occur due to measurement errors, data entry mistakes, or genuine rare events. Detection methods include a statistical, using z-scores or IQR, interquartile range, a visualization, box plots or scatter plots. Handling outliers depends on context, remove if caused by errors, or keep if they represent meaningful insights. For example, extreme sales during a holiday season may be valid. Proper handling ensures accurate statistical analysis and prevents skewed models, leading to more reliable results in decision-making. 13. How do you assess the quality of your data? Data quality is assessed using key dimensions. Accuracy. Data reflects reality correctly. Completeness. No missing essential information. Consistency, uniform across datasets. Timeliness. Up to date for current use. Validity. Conforms to required formats and rules. Uniqueness. No duplicates. Assessment involves profiling data, running validation rules, and using automated data quality tools. Poor quality data can undermine analytics projects, while high-quality data ensures trustworthy insights. Regular monitoring, cleansing, and governance practices maintain quality over time, ensuring that analysis leads to sound and actionable business outcomes. 14. What is the difference between a database and a data warehouse? The database stores current operational data, optimized for transaction processing, OLTP. Examples: MySQL, PostgreSQL. Data warehouse stores historical, aggregated data from multiple sources, optimized for analytical queries, OLAP. Examples: Snowflake, Amazon Redshift. Databases are used for day-to-day operations, while data warehouses are designed for business intelligence and reporting. Warehouses enable complex queries, trend analysis, and data mining. In short, databases handle real-time transactions, whereas warehouses support strategic decision-making by providing a consolidated, historical view of business data across departments. 15. How do you deal with large datasets that cannot fit into memory? When datasets exceed memory capacity, analysts use a chunking, process data in smaller batches, distributed computing tools like Hadoop or Spark for parallel processing, cloud-based solutions, AWS, Google BigQuery for scalable storage and querying, sampling, analyze representative subsets if full dataset processing isn't required, database queries, use SQL to aggregate before loading into memory. Efficient memory management ensures speed and prevents crashes. Choosing the right method depends on analysis goals, data structure, and available resources, ensuring scalability without compromising data accuracy or insight quality. 16. What are some common statistical techniques used in data analysis? Common techniques include descriptive statistics, mean, median, mode, variance, probability distributions, normal, binomial, hypothesis testing, t-tests, chi-square tests, a regression analysis, linear, logistic regression, ANOVA, compare means across groups, correlation analysis, Pearson, Spearman. These methods help identify relationships, trends, and patterns, making them essential for predictive modeling and data-driven decision-making. Statistical techniques form the foundation of sound analysis, ensuring results are based on evidence rather than assumptions, thus enabling more accurate and actionable insights for businesses and researchers. 17. How do you ensure data privacy and security during analysis? Ensuring data privacy and security involves access control, restricting data access to authorized users, encryption, protecting data at rest and in transit. Anonymization, removing personally identifiable information. Compliance, following regulations like GDPR, HIPAA. A secure storage, using trusted servers or cloud services. Audit trails, monitoring access and changes. Privacy and security are crucial, especially when dealing with sensitive information like healthcare or financial data. Proper safeguards prevent data breaches, protect user trust, and ensure legal compliance, maintaining the organization's reputation and avoiding costly penalties. 18. What is the role of machine learning in data analytics? Machine learning, ML, enhances data analytics by automating pattern recognition, classification, and prediction tasks. ML models can handle large, complex datasets to uncover insights that traditional methods may miss. Examples include customer segmentation, fraud detection, and demand forecasting. In analytics, ML shifts the focus from descriptive insights to predictive and prescriptive outcomes, allowing businesses to anticipate trends and make proactive decisions. Integrating ML with analytics improves accuracy, reduces manual work, and scales analysis capabilities, making it a powerful tool in modern data-driven strategies. 19. How do you communicate your analytical findings to non-technical stakeholders? To communicate effectively, simplify language, avoid technical jargon, use visuals, charts, graphs, and dashboards to illustrate trends. Tell a story, explain the problem, findings, and implications in a logical flow. Highlight key insights, focus on what matters for decision-making. Provide recommendations, offer clear, actionable steps. Good communication bridges the gap between analysis and action, ensuring stakeholders understand the insights and can confidently make informed decisions. Effective storytelling transforms raw numbers into compelling narratives that drive organizational change and strategic planning. 20. Can you give an example of a data-driven decision you contributed to? In a previous project, I analyzed customer purchase data to identify declining sales trends in a specific product category. Using sales history, customer feedback, and market research, I discovered the issue was due to outdated packaging and limited marketing. I presented visual insights and recommended a targeted campaign and updated design. Within 3 months, sales improved by 25%, validating the analysis. This experience showed how data-driven insights can directly impact business performance, reduce guesswork, and deliver measurable results through evidence-based strategies. Preparing for a data analytics interview involves understanding concepts, tools, and real-world applications. By practicing these questions, you'll be ready to demonstrate your analytical skills, problem-solving abilities, and business insight. With the right preparation, you can confidently showcase your value as a data-driven professional ready to make impactful decisions.